Hey guys, so today I'm going to go over the Virtual Challenge 3 calculator test. Let's get started. We'll just be going over the word and geo questions. So, question 6, Jane bought 3 tax-free items for $3.75, $7.92, and $5.50. If she paid for the items with a $20 bill, how much change did she receive? That's pretty easy. All we need to do is take our initial $20 that we have and subtract the sum of these tax-free items. So we're going to subtract the sum of 3.75, 7.92, and 5.55, leaving us with $2.78. Not sure if you can see that. It's kind of blurry. So that's our answer choice. That's our answer. And now, number 7. Find the square root of the product of 218 and 379. It's also pretty easy. We're just going to take the square root of their product, click enter. We get about 287. Question 8. What is 33 times the average of 17, 39, and 71? So to get the average of 3 numbers, you got to get their sum and divide by how many numbers there are. So we'll divide by 3. We're going to take this average and multiply by 33, and we get about 1400, which is our answer. Moving on to the first geo of the test, we have a circle with radius 7.34. We want to know its circumference. So the formula for the circumference of a circle, C is equal to 2 pi r, right? And so we know what our r value is, so we can substitute that in there. Type it on our calculator, 2 times pi times 7.34. And we get about 76.1, which is what we got here. Now we have the area of a square here being 222, and we want to know this diagonal. So the area of a square is just side squared. And to get the diagonal of a square, the shortcut is your diagonal is equal to your side length times the square root of 2. So we have our area, 222. So let's just get the square root of that. And now we have our side length. We're going to take that value and multiply by the square root of 2. And we get about 21.1. Alright, so question 16. What is the percent decrease in the speed of light when it goes from crown glass traveling at 197,234 kilometers per second into flint glass traveling at 113,509 miles per second? So this is a percent decrease question. And so an example would be like, what's the percent decrease when I go from 10 to 7? And so you want to treat that like a percent change question. But, as you'll see here, I have 10, enter, 7, I do yellow percent change here, and I get negative 30. But that's not the answer we want to put. Instead, because it's percent decrease, we don't include the negative. So if we were to write that on our test, we'd only put 30%. We'll do the same thing here, but the extra part is that we have kilometers per second and miles per second. We gotta make sure these are in the same units. So I'll change kilometers per second to miles per second. And the way we're gonna do that is I'm gonna type 197,234 here on my Nspire. I'm going to go to this little book icon right here. And so I click that, I go to the third option here, and I have this little tool called Conversion Assistant. And so I'll click that. And I get to choose what category of units I'm converting. And so there's one for velocity here. So I want to change kilometers per second to miles per second. So I'm changing from kilometers per second to miles per second. And I get about 222,556 miles per second. And so now I can compare these two values. So I'll type what I just got, 122,556, and then I'll type 113,509. I'll do percent change, and I get negative 3.38. But remember, for percent decrease, we don't want to include that negative. So we'll only write 7.38, which is our answer. Number 17, if all Florida oranges yield 6 tablespoons of juice, how many Florida oranges must be squeezed to make an 18-ounce glass of juice? So this is another conversion question, so we'll use Conversion Assistant again. So I'm going to change 6 tablespoons into ounces so I can compare. So I'll type 6, go to the book icon again, go to Conversion Assistant, and this time tablespoons and ounces are units of volume. So I'll change the category to volume, and I'm changing from tablespoons. So I'll go find tablespoons right there. And I'm going to ounces. So I'll go to US fluid ounce. And so I get that 6 tablespoons is equal to 3 fluid ounces. So that means one Florida orange has 3 fluid ounces of juice. So if I want to make 18 glasses of juice, I'll have to use 18 ounces. And knowing that I have 3 ounces of juice in a tablespoon, I'll just divide those two values. So I get that I need 6 oranges to make 18 ounces of juice. So our answer is 6. And we write this as 6 and not with 3 significant figures because this is an integer question, so it wants an integer answer. Number 18, Tom saves his spare nickels, dimes, and quarters into a jar on his dresser. He currently has a total of 480 coins for $80.65. He has 67 more quarters and dimes. How many nickels does he have? So we can write a system of 3 equations. We can do that on our Nspire. We'll just go menu, algebra, system of equations, solve system of equations, and we're going to use 3 equations because we have 3 unknowns. Those 3 unknowns being the amount of nickels, dimes, and quarters I have. So for convenience sake, I'll call x the number of nickels, y the number of dimes, and z the number of quarters that I have. So we know that there's a total of 480 coins in the jar. So I can just simply write x plus y plus z equals 480. For our second equation, the second piece of information we're told is that all of these coins are worth $80.65. So I can multiply x by the value of it, so that being a nickel. So I'll just multiply by 0.05. I'll add y, the number of times, times the cost of a dime, is 0.10, and z, the number of quarters, times the value of a quarter, 0.25, and I'll set that sum equal to 80.65. And for the last equation we can write, the last piece of information the question gives us is that he has 67 more quarters than dimes. So I can write that as z equals y plus 67. I click enter, and it gives me the number of nickels, dimes, and quarters I have. The question wants to know how many nickels I have, so I'm looking at my x value. And as you can see, that is 67. So I have 67 nickels. That's my answer. So for 19, this is a basic trigonometry question. We're just going to use SOHCAHTOA. So I have this hypotenuse here, and I want to know what the side opposite of this angle is. So when I have an opposite side and a hypotenuse, it's a sign that I'm using sine. No pun intended. So here, I can set my opposite side equal to 21.4 times the sine of my angle here, which is 64 degrees. Now it's important to make sure that you're not in radian mode when you do this. Make sure your calculator is set in degree mode. All right, 21.4, enter, 64, sine, multiply. I get 19.2, which is my answer. For 20, we have the area of this right triangle, and we want to know its hypotenuse length. So the area of any triangle, is equal to the length of the base times the length of the height divided by 2, right? So I have the area, I have the length of my base, I don't have my height, so I can solve for that using this equation. So I'll just work backwards to find my height. I take my area of 12.6, multiply by 2, and divide by my base. So I get that my height is 4.87. And now to get my hypotenuse, I can just use the Pythagorean theorem, which says that c is equal to the square root of a squared plus b squared, where c is your hypotenuse and a and b are your base and your height. So I can take this value that I just solved for, square it, add it with the square of my base, take the square root, and that's my answer, 7.11. Number 26. Diane took a trip from Plano to Andrews, a distance of 372 miles. If she made two 30-minute stops to gas up and rest, how long did her trip take if her average driving speed was 63 miles per hour? Okay, so we have the distance between the two cities, and we know she took two 30-minute stops, so about 1 hour of rest. And we also know that we want her average driving speed to be 63 miles per hour. We want to know how long this trip took. So we're solving for time. And so what I can do is I can set up an equation on my nsolve program. So let me write it out here for you guys. And so I can say that my average speed is equal to my distance divided by my time. So if my speed is 63 miles per hour and my distance is 372 miles, I can solve for the time that took, which would be 5.9 hours. So I'll multiply that by 60 to convert it to minutes, but that's just my average driving time. I'm not also accounting for those two 30-minute stops. So after I turn, this hours into minutes, I gotta add back those two 30-minute stops. So I gotta add back 60 more minutes. So this is why I added 60 here. And we get a total of 414 minutes that the trip took, which is our answer. Number 27. If Jim invests $96,000 at 5.25% annual interest compounded quarterly, how much interest will be made after 6 years? So the equation to know here is that our final amount is equal to our initial amount times 1 plus our rate divided by how much we're compounding it by, all raised to the power of how many years, so time, times how much we compounded it per year. And so I can write this on my calculator like this. So to get that final amount that Jim has, I'll take the initial amount of money he had, which was $96,000, times, I open parentheses, 1 plus our rate, which is 5.25%, so I can write that as 0.0525. We know it's compounded quarterly, so I'm going to divide it by 4, close parentheses, and raise it to the power of 6 years times how much I compounded it. So that's 4. I get that the final amount of money that Jim makes is $131,275.60. But that's not what the question is asking for. It's not asking for the final amount of money that Jim has in his account. It's asking for how much interest he made. And so the formula for your interest is equal to your final amount minus your initial amount. So it's how much money you made. So I'll take this final amount that I calculated and subtract it from the initial, or subtract the initial, $96,000, and now I'll get my answer of $35,275.60. 28. Will and William lunch at Southern Barbecue. Will's meal cost is $17.71, and William's meal cost is $19.35, both pre-tax. The tax rate is 8.125%. If they left $48 on the table, how much was the tip for the waiter? This is also a pretty easy question. We're going to take our $75 that's left on the table, and we're going to subtract the cost of the food, leaving us with the tip amount. The cost of the food was, well, Will's meal costed $17.71, and William's cost $19.35. But I gotta multiply that by the tax rate. And that leaves me with $7.93. $7.93 as a tip. And that's my answer. Number 29. So I have a sphere with a surface area of 3020, and I want to know its volume. So we can work backwards here. The surface area of a sphere, I'll write this a little bigger, surface area of a sphere is equal to 4 pi r squared. And the volume of the sphere is equal to 4/3 times pi r cubed. And so, given my surface area, I can solve for my radius, and I can go and plug it into my volume equation. So I'll do my surface area, which is 3020, and I'll divide by pi, divide by 4/3, cube rooted, and that's my radius. Oh wait, I worked backwards in the volume. Okay, let's do that again. So we're going to take our 3020, divide by 4 pi, square rooted. Again, my radius is 15.5. I'll cube that value and multiply by 4/3 and multiply by pi. And I get my volume is 15,600. Number 30. So I want to know the volume of the square pyramid. I'm only given the side length of the square base and this angle here. So the volume of a pyramid, of any pyramid, is the area of the base times height divided by 3. It doesn't matter if you have a hexagon base, a circle base, a square base. This will always be the case. And so I can find the area of my base really easily. It's just side squared. But to get the height, well, that's an unknown, so I got to solve for it. And using this angle, I can use trigonometry to solve for this height. Just use SOHCAHTOA. So I would be able to solve for this length, and I could use it in my equation. Like, let me draw a little graph here. It's like if you're looking from this way. So I have my 63 degrees here, and I can get this length. It's half the diagonal of the square, and I can use this side and this angle to solve for my height. So if you remember from earlier, the diagonal of a square is equal to the side length times the square root of 2. So I'm going to take my side length of 720, multiply by the square root of 2, and half it, and that is this length right here. And I get about 509. And so now I have the side which is adjacent to my angle, and I have the side which is opposite to my angle. So that's a sign that I'm going to use tangent. Specifically, I'm going to multiply this side length right here by the tangent of 63 degrees. Again, make sure your calculator is in degree mode. So I'm going to take my 509, multiply by the tangent of 63, and that gives me my height. I'm not done yet. I need to substitute that height back into this volume equation. So I'll multiply by the area, which is 720 squared, and I'll divide by 3, and I get my answer of 1.73 times 10 to the 8th. Number 36. How many minutes after 7:15 do the minute and hour hands align? So the trick to use here is that the minute and hour hands align some multiple of 12 over 11 hours every cycle. And so like at noon they're aligned, then 12 over 11 hours later they're also aligned, and the next 12 over 11 hours later they're still aligned. And so I can multiply this factor of 12 over 11 by 7. So that would be the 7th time they're aligned, afternoon, right? I can convert this time in hours to minutes, and I can subtract this time here of 7 hours, 15 minutes. Well, I'll convert it to minutes first. So that's 435 minutes afternoon. So I can subtract these two times to see when the next time they align is. And I get 23.2, which is our answer. Number 37. Find the distance between the intersection points of y1 equals 0.4x squared minus 6 and y2 equals 0.3x plus 2. So this is a really easy question. You could just graph this on your n-spire. So I'll type the first equation, which is 0.4x squared minus 6. Now I'll type the second equation, 0.3x plus 2. And you can see already where the two intersection points are. So I'm going to go to Menu, Geometry, Points and Lines, and Point, or just Menu 811. And so I'm going to plot a point on each of these intersection points. So here it says intersection points, I plot it. I go to the second intersection point, wait till it says intersection point, and then I plot it. And then, to get the distance between these two, I go back to Geometry, Measurement, and Length, or Menu 831. And I click these 2 points, and it tells me the distance between them, which is 9.34 units, or 9.37. And that's our answer. Number 38. Nathan and Tommy run a 440-yard race. Tommy runs a mile in 6 minutes 46 seconds. Nathan runs a mile in 8 minutes 48 seconds. How far ahead is Tommy just as he finishes, or just as he crosses the finish line? So note that we have our rates in miles per minute, or minutes per mile, my bad. We have our rates in minutes per mile. And we're given that the distance here is in yards, 440 yards. So one thing to memorize is how many yards are in a mile and how many feet are in a mile. So I'm going to turn this distance in yards to miles first. So there are 1760 yards in 1 mile. And there are 5280 feet in 1 mile. So these two numbers you should memorize. But of course you can use the conversion assist on your calculator, but it's just faster to memorize these values. And so we get that this race is actually 1/4 of a mile. And so now that we have our distance here, we can write this equation. So we know that the distance is 1/4 of a mile, so I'm going to multiply that by the faster rate, which is Tommy's, which is 6 minutes 46 seconds per mile. I'll get that he finishes the race in 1.69 minutes. And so I can divide this time by Nathan's rate of 8 minutes 48 seconds per mile, and I get that at this time he's run 0.192 miles. And so I convert that into yards by multiplying by 1760, and I get that he's run 338 miles. I'll subtract this from, 338 yards. And so I'm going to subtract that from the initial 440 yards, and I'll be left with 102 yards. So that's how far ahead Tommy was as he crosses the finish line. And so that's our answer here, 102 yards. Note that I passed for miles here, you'd have to, convert. So pay attention for what units that the question wants you to answer in. Okay, number 39, a scaling triangle and a circle. So here is where us Mission Collegiate guys, or I guess like anyone else who has this program, this is like where it's specifically catered towards us. So we have a program where if you have this circumscribed triangle inside of a circle, then given the three sides of this triangle, it'll give you the radius of this circle. But we don't have all three sides of the triangle. So to do that, like to fix this, what we can do is, using geometry, we know that if we take like this vertex right here, I want you to imagine like these 2 points are fixed in place, and I can freely move this point anywhere around the circle. Well, as long as it's in this range right here, the angle should remain the same because it encompasses the same arc length. So if I were to draw a point here which is directly perpendicular to this part right here, if I were to draw a triangle like this, it would still have an angle of 65 degrees. But now, note that this triangle's hypotenuse is now the diameter of the circle. Why is it the diameter? It's because this angle right here, this 90-degree angle that I've now formed, it encompasses half the circle's arc. So half the circle's arc lies above this hypotenuse and below it. So it's the diameter. And I know what this length is. It's 414. So I can use SOHCAHTOA to get the diameter of this circle. And so I'll just do 414 divided by the sine of 65 degrees. And that gives me my diameter. And to get the radius, I just divide by 2. So in this case, even though we didn't have all three sides of our triangle, we didn't actually have to use our program. All we had to do was just manipulate this triangle right here, knowing the property that these angles are going to remain the same. So now that I have my radius, I can square it and multiply by pi to get the area of the circle, and I get about 19,800, which is my answer. Okay, number 40. So we have a scaling triangle, we have a few side lengths, an angle here, and I want to solve for this angle in degrees. So one thing I can do is I can solve for this side of the triangle. Now I'd have all three sides of the triangle. I'd have this side, this full side, I would just add these two lengths, and this whole side. And now that I would have all three sides, I can use the law of sines by stating that the sine of this angle over this side is equal to the sine of this angle over this side. So I'd have one unknown which I could solve for, which would be this angle. And so the two equations to know here are the law of cosines and the law of sines. So the law of cosines states that c squared, and c is not necessarily your hypotenuse. It could be any side of the triangle. So this works for scaling triangles, isosceles, right triangles, all of those. C squared is equal to a squared plus b squared minus 2 times a times b times the cosine of angle C. And so I'll write on another piece of paper, kind of diagram it for you. I'll just write this triangle. right here. Now say I have side A, B, C, and angle A, B, and C. So if I wanted to find the side length C, I would do A squared plus B squared minus 2 times sides A and B times the cosine of angle C. Angle C is the angle directly opposite of side C. Same as angle A is opposite of side A, and angle B is opposite of side B. And the second equation to know is the law of sines. The law of sines states that sine of angle A over side A is equal to sine of angle B over side B. And let me pull out this diagram again. So the sine of this angle over its side is equal to the sine of this angle over this side. So it's like a proportion. And so I'll call this side A and this side B for now. And I'm solving for side C using the law of cosines. And I have angle C. If I did not have angle C, I wouldn't be able to solve for this side. But I do, so I can use the law of cosines. So I can type on my calculator the square root of A squared plus B squared, which is these some of these two segments. So 7.2 and 3.58. We square those. Minus 2 times A times B times the cosine of my angle, which is 46. And I get about 8.2040, decimals. We'll just say 8.204. And now I can use the law of cosines. So I'll call this side here A and this side here B, meaning I would have angle B right here and angle A right here, and I'd be solving for angle A. So I can do an n-solve equation here. Sine of angle A, which I'll call x, because that's what we're looking for, over its opposite side here, which is 4.81, equals the sine of 46 over the side that we just solved for, 8.24, or 8.204, comma x, and you'll get this. Now, don't be scared, the calculator's not broken. All it means is that there's an infinite amount of solutions where this little n1 right here means you can substitute any natural number and it'll be a solution to the equation. And so 9 times out of 10, you just want to make that 0. So we're just going to do 360 times 0 plus 0.06929117. That's probably good enough. And we get our angle as 24.9. So that's our answer. Number 46. A recipe calls for 6 cups of sugar and makes 15 dozen 4-inch cookies. How many cups of sugar are needed to make 24 dozen 6-inch cookies? So question 46 is always what we call a sizing problem. And it has to do with a dimensional analysis between two objects, right? So here I have 6 cups of sugar and 15 dozen 4-inch cookies. So we got a piece of paper here. And so I had 15 dozen, which is just 180 4-inch cookies. and that took 6 cups of sugar. I'll set that equal to this 24 dozen, which is just 288, and that's 6-inch cookies. And I want to know how many cups of sugar, so I write X. So this proportion I have here, it shows that the length of the cookie is directly proportional to how many cups of sugar it has. That's why it's like this number over this number. It has to be constant. Same thing for this. And I just multiply the number of cookies I have up here with the length. Now, what makes this a dimensional analysis question is you got to compare dimensions of the two objects. And so I know for a fact that cups of sugar, well, what is that? That's not length, it's not area, it's volume, right? Because I can store it in a container and it takes up volume. So this bottom column, or bottom row, which symbolizes cups of sugar, that represents a 3-dimensional entity. Now on this top here, looking at the inches, right, 4-inch cookies, well, that's not volume. I can't store 4 inches of something in a container. Now inches is length. That's a 1-dimensional entity. And I can't compare two things of different dimensions. So the way I'll fix that is by turning them into the same dimension. So one way I could do that is by cube rooting the bottom here. I get the cube root of 6 equals cube root of x here on the bottom. Now I would turn this 3D entity into a 1D entity. Or I can cube the lengths, which is what I'll do. Now it turns this into a 3-dimensional entity. So now I'm comparing 3D and 3D entities. And so now I've got this proportion set up, and I can solve for x. And I get 32.4 cups of sugar. And now, one thing to keep in mind is that sometimes the question will include a little sentence at the end that says that the cookies have a constant thickness. So if one dimension is held constant, in this case the thickness or the height of the cookie, that means it doesn't scale like a 3-dimensional entity, because not all 3 dimensions, length, width, and height, are scaling. It's only going to be length and width, meaning that cookie would scale like a 2D entity. So that's something to keep in mind. Okay, 47. Helen started a workout program at her gym. It includes running on the treadmill. She has gradually been increasing her time spent running each week. The total time spent running for each of the first 5 weeks were 22 minutes, 26 minutes, 31 minutes, 33 minutes, and 42 minutes. Predict how many minutes she'll run on week 12. And so, question 47 is always a statistics question. And 9 times out of 10, you're doing a linear regression, unless you're told otherwise. Like it's proportional to the square of something, or it's like an exponential growth. 9 times out of 10, it's linear, unless you're told otherwise. So we're going to do a linear regression here. And so to do that, we're going to pull out our nSpire. We're going to go to lists and spreadsheets. And so here I'll label my A column X, my Y column Y, or my A column, like these top 2 columns X and Y. So X is going to be my dependent variable. And so that's going to be the number of weeks that she spent running. So 1, 2, 3, 4, 5. And Y is the dependent variable, right? So X is independent, Y is dependent. And so the number of minutes that she runs is dependent on the number of, on which week it is. So week 1, she ran 22 minutes. Week 2, 26. Now just fill this column down. So these are all my data points. Now that I've got them all entered in, I can go to menu, 4 for statistics, 1 for stat calculations, and 3 for linear regression. It wants my X and Y list, so I'm just going to type X here, tab to go to the next column down, type Y. That's the only thing you need to enter. So I'll double click enter, and I get my equation in the form of y equals mx plus b, where my m is my slope, which is 4.7, my b is my y-intercept, which is 16.7, and then some other important things to note here, like our R value is our correlation coefficient or regression coefficient. Sometimes the question will ask for the correlation coefficient of a set of numbers, and this is what you'd want to look for. But we want to predict how many minutes she's going to run on week 12. So I'm just going to substitute 12 in for x in the equation 4.7x plus 16.7. I'm going to do 4.7 times 12 plus 16.7, and I get that I predict that she's going to run 73.1 minutes on week 12. Question 48. If there's any word problem you should answer, it's this one. This one's always a free question. You just got to use your nsolve function on your calculator. So it just wants to know what value of x satisfies this equation. So we're just going to go menu 3.1 to get our solver, and we're just going to type this equation in. So x to the 8th minus x to the 5th equals negative x plus 3 comma x, and I get two values. I get negative 1.115 and positive 1.199. Now, which one do I put in the answer choice? Well, you got to make sure you read the question correctly. It wants to know what negative value of x. If it asks for positive, we put the positive results that it gave us. But because it wants the negative, I got to input the negative one, which was about negative 1.12. Okay, question 49. Cone and hemisphere. So we know that the hemisphere's surface area is equal to the cone surface area. And so the surface area of a hemisphere. So I already told you guys that the surface area of a sphere is 4 pi r squared. So you'd think that the area of a hemisphere has to be half of that, because it's half the sphere. And that's like a good guess, but it's not exactly correct, because this whole sphere here, that's just the outside. And so if I got half of that, that would encompass this little curved part here, this little shell on the outside of this hemisphere. That would be 2 pi r, or half of a regular sphere surface area. But now I've uncovered this circle right here. So that's an additional pi r squared that adds to the surface area. So actually the surface area of a hemisphere is 3 pi r squared. Just have this memorized. And so this is the area of the hemisphere surface area. I can set this equation equal to the equation for the cone surface area. Now the cone surface area is a little bit more tricky. I have this cone here. There's two parts to the surface area. There's the circular base on the bottom, that's just pi r squared. But then we have this lateral surface area here on the top. And so the lateral surface area of a cone is pi times r times your slant height. And my slant height is this little, well, slanted height right here. It's like the hypotenuse of the cone. And to solve for your slant height, well, you just do Pythagorean theorem by drawing this right triangle here. So it's like a hypotenuse. That slant height is equal to the square root of a squared, which is our radius, plus b squared, which is our height. And so I'm given only the radius of the circle. So I can write this equation. I can write the surface area of the cone, which is pi times our radius, which was 488 squared, plus our slant height, or pi r slant height, my bad, plus pi times our radius times our slant height, which I'll write as the square root of 488 squared plus our height squared. I just put h because it's unknown. So this is the cone surface area. Now set that equal to the hemisphere surface area, which was 3 pi r squared. And I can set this into my end-solve equation on my calculator to solve for our height h. So I'll type that right now. Menu 3,1, go to the solve function, pi times 488 squared plus pi times 488 times the square root of 488 squared plus h squared, I will put x, equals 3 times pi times 488 squared, comma x. And again, my height is about 845.2. And so now I wanted to solve for this whole length right here. And this whole length is, well, my height of the cone plus the radius of the hemisphere. So now that I have my height, the 845.2 that I solved for, I'll just add that, my radius, 488, and I get about 1,330 as my answer. Number 50, so I have a hollow frustrum. Now I have the volume, and the reason it's hollow is because it has this cylindrical cavity right here. And so here we need to know the volume of a frustrum. So the volume of a frustrum goes like this. The volume is equal to pi times our height over 3 times little r squared plus big R squared plus little r times big R. Like that. And so I can substitute my known values here to get the volume of my frustrum. So pi times our height, which was 22.6, over 3 times little r squared. So here I have the diameter, so I gotta half it. That's about 7 or 5.7 squared plus big R squared, which I don't know this diameter, so I don't know the radius. So I would just put x over 2, x being the diameter, which is what I'm solving for. So little r squared plus big R squared plus little r times big R. Like that. This tells me the area of my frustrum. But I gotta subtract the cylindrical hollow cavity. So I subtract pi times the area of my area of the base times height gives me the cylinder's volume, so pi r squared times height, which was 22.6, And this is my volume of the hollow cluster, which I'm told is 5,310. So I can set this whole equation equal to that value and solve for x. So I'll just type that in my solver. So menu 3,1 pi times 22.6 over 3 times 5.7 squared plus x over 2 squared plus 5.7 times x over 2 minus pi times 5.7 squared times 22.6 equals 5310 comma x, and I get that my length is either negative 40.2, which is not possible, we can't have negative lengths, or positive 28.8, which is my answer. Number 56. So here is the rad symbol, right? That means radians. So that means we're going to do this problem in radians. So it tells us for what value of x, which is between 0 and 20, does the slope of the curve y equals 2 times cosine of x over 4 equal 0.447. So this is a calculus question. So it does help to know a bit of calculus here. There's some great videos on Khan Academy about calculus. And so I'd recommend that you watch those videos about derivatives specifically before watching the solution. So it's going to use some calculus. So we have our curve, which I don't know exactly what it looks like. Probably like this, maybe. Right? And I want to know what value between 0 and 20 does the slope of this curve, so that's the slope at a specific point, this tangent line, and that slope is equal to this value. So as you should know, like the slope at a point is the derivative at a point of a function. So there's actually a program installed on this calculator that tells you the derivative at a point of a function. So I just got a menu calculus derivative at a point, or menu 4.2. And here I have my variable x, which is fine, and the value of that point, which is what we're solving for. We want to know for what value of x. So I'll just put a. All right, a is going to be our unknown. And so I'm just going to copy this and put it into an n-solve equation. And the reason I'm doing that is because I'm going to set this derivative at a point equal to that value, 0.447. So the derivative, and make sure we're in radians, so here it's in degrees, I'll just click that, turn it to radians. So our equation, let's type it in here, 2 times cosine of x over 4, go to a, I'll put parentheses around this whole function, that's equal to 0.447. And I'm solving for what value of a, like for what value of a for x equal that slope. And so I get, this mess, which again, you just want to put 0 in for n1 typically. So I have this, or, it says over here. So I'll just move to the right, this. So I'm going to use this, because if I plug in 0 here, I'd get a negative answer. So I'll plug in 0 here, I get a positive 1. Times 0 plus 6.676 And I get that my value of x should be about 17, which is my answer. And so let's also graph this just to kind of get a look for the equation. So I'm just going to change my bounds to be from 0 to 20. So this is my graph. And so at 17, so let's say it's like this point right here, right? At that point, that is where my slope is about equal to that value. So it's kind of close. I'm just kind of guesstimating. That's kind of visually what it looks like. Okay, number 57. So I would usually say that number 57 is probably like the hardest question on the test. It's usually like a kind of like a tough applied calculus question. So in this case, it's a related rates question, which I'd also suggest that you watch some Khan Academy videos on related rates, kind of get, brushed up on that topic. Like I would say, like if you're like not super great at calculus, you might want to skip these two questions usually on your test. There's a lot easier questions that you can use with your time instead of solving these two. So, but the solution for 57 goes like this. So we have a 13-foot ladder which is leaning against a wall. So I'm going to draw that right here. So I have a wall and a floor, and I have a ladder. Like that. So this ladder is 13 feet. Okay, so this is a 13-foot ladder leaning against the wall. The base of the ladder is being pulled away from the wall. So it's being pulled away at 1.27 feet per second. At what rate is the top of the ladder sliding down the wall? I want to know what that rate is. At the moment, the base of the wall, or the base of the ladder, is 5 feet away from the wall. It's like 5 feet here. And so this is like a classic related rates question, like the ladder sliding down against the wall. So one way we can write this is, we can write x to symbolize the distance of the base of the ladder from the wall, and y as the distance from the top of the ladder to the floor. So I could say x squared plus y squared is always equal to 13 squared, right? Because at any point, like here, the length of the ladder is constant, 13. And so what I can do here is I can implicitly differentiate this question, or this equation, and I'll get 2x dx dt. I'm implicitly differentiating with respect to time, because we're given this rate in feet per second, so that tells me I have to differentiate with respect to time. So 2x dx dt plus 2y dy dt equals 0, because I take the derivative of a constant, it's just 0. And so, these 2's, I can just divide them out, and I can kind of move this expression to be more clean. I'll get that x dx dt equals negative y dy dt, right? And so what I can do here is I can substitute my value of x that I have here, which is 5 feet away from the wall, times dx dt, which, let's think about what that means in context. That's the change in the x with respect to time. It's like the rate at which x is changing. And so what would that be? That would be this value. This rate at which the base of the ladder is being pulled away from the wall, which was 1.25 feet per second. And that has to be equal to negative y, which I don't have my y, but I can easily solve for it using the Pythagorean theorem. Because this is a right triangle, right? And so if I have 13 and 5 here, I can just do the square root of 13 squared minus 5 squared to get my height, which would just be 12 feet. So I would put 12 in here, times dy dt, which, what were we solving for initially? Well, if you look back at the question, it tells us that we want to know at what rate the top of the ladder slides down the wall. And that would be dy dt, right? The change in the height over time. So that rate at which it's sliding down. And so I can solve this equation for dy dt and get my answer. So I'll just do 5 times 1.25 divided by negative 12. That tells me the rate at which the height of the ladder is moving is negative 0.521. But we don't include the negative because we want to know the rate at which it's going down. So that'd just be 0.521 feet per second, which is our answer. Of course, you want to keep in mind your units. Make sure, they don't like pull a fast one on you, and this is inches per second. You do all this hard work, and you just mess it up like that. Always be mindful of your units. Okay, 58. So 58 is also one of those questions you kind of always want to answer. Like 40. Was it 40? 48. This is the matrix question. This is always a matrix question. Given that A is this matrix and B is this matrix, we want to find the value of x such that the determinant of the product of these two matrices is 69,882. So I can write an n-solve equation. So N(3)(1), and I'm going to set the determinant of the product of these two matrices equal to this value that gave me. So I'm going to write 69,882 is equal to the determinant of these of the product of the two matrices. And to get the determinant, I go to menu 7 for matrix and vector, and 3 for determinant. And inside here, I'm going to write the product of my two matrices. So to write a 2x2 matrix, I go to menu 7 again for matrix and vector, create matrix, or just to memorize, menu 711. And it's already set to 2x2, so I'll just click enter. And I type in my values, which were x, 3, x, and 11. And I'm not using the arrows to, go through each one. I'm just pressing tab. So it goes like first row, first column. I do tab, it goes to the next column. Do tab again, it just goes down. Kind of like this Z pattern, just like that. It's just a way to quickly write those. I'll just do menu 711 again. So enter. I type in the values in that matrix. Oops. Okay. It's like that, right? Now at the end here, I'll do comma x because I'm solving for my x value. And I get 2 answers. But remember, gotta pay attention to what the question's asking for. It wants the positive value of x. So I ignore this negative solution and I write the positive one, which is about 8.88, which is my answer. Okay, 59. So what this graph is basically communicating is I want to know the sum of the x and y coordinates of the minimum of this function. And so this is actually a pretty easy question. It gives me the equation here, so I'm just going to graph it. My graphs page. I'll write the equation. Alright, so I had to zoom out a bit because I wrote it and this default screen doesn't show, so I'll just do menu 4 for window and zoom, and A so that auto fits the graph onto my screen. And so now I can see the graph. And to get the minimum, I go to menu, analyze graph, so 6, and minimum 2. Or just menu, just to memorize, menu 6, 2 for minimum. And so it's asking for the lower bound. So I read like somewhere, I'll put it somewhere here. And the upper bound doesn't matter. I just like, kind of put it all the way out here. And I get that my minimum and the coordinates of my minimum are 1.41 and 17. So I just add those and I get 18.4, which is my answer. Okay, question 60. So I have right triangles and a quarter circle. So this quarter circle right here and this triangle. Okay, so it's a little bit of a tricky question. One thing I could write is I can label what I know. So I know that this is my radius, this distance right here. It's my r. I also know that this distance is also r. Right? This distance right here and this distance are equal. And I want to know the degree measure of this angle. So what I can write is a proportion to solve for my r, and then using my r, I can use SOHCAHTOA to solve for my angle. So how can I write a proportion? Well, I see there's this triangle right here and this bigger triangle right here. I have similar triangles, I can make a proportion. So the proportion now writes is the proportion of the heights to their bases. Okay, so I know that the height of the small triangle is 22, as shown here, and the height of this big triangle is 30. Let me just kind of darken this for you guys. I know it's been kind of blurry with the video. I tried messing with the settings beforehand. This is like the best it could have gotten. Okay. Now I can write the ratio of the bases here. I know that the base of my big triangle, it's going to be this whole length, is just my radius. So I can just put r. But what can I put here for the base of my small triangle? So this is where we have to get like a little clever here. So what I did was I did Pythagorean theorem. So I can say that this base is equal to the square root of my hypotenuse squared minus my height squared. So my hypotenuse is r, so r squared minus my height squared, which is 22 squared. And so that's what I put here for my base. Kind of hard to see. It says like a square root of r squared minus 22 squared. So I have the ratio of my small triangle's height and base is equal to the ratio of my big triangle's height and base. So I can use nsolve to solve for my value of r. So 22 over the square root of x squared minus 22 squared equals 30 over x, comma x. And I get that my value of x is about 32.36. So r is about 32.36. And so now that I know my value of r, I can write that here, so 32.36. And I can solve for my angle now, because I know what my height of this big triangle is. I know what my base of the big triangle is. So I know this opposite side and this adjacent side. So that's a sign that I'm going to use tangent. So I know that the tangent of my angle is equal to opposite over adjacent. So my opposite is 30 over my adjacent, which is 32.36. And so I'll just do the inverse tangent of both sides. I'll do the inverse tangent of 30 over 32.36. Oh, and this is another reminder to make sure you're in degree mode when it wants to in degree mode. Because I'm still in radians here, so I gotta change that to degrees. I just enter this equation back, and now I get in degrees. And I get 42.8 degrees as my angle. So that's my answer. Last page. Okay, question 61. What is the closest approach of the line y equals 2x plus 7 to the origin? Okay, so there's two ways of doing this, and I'll show you guys the way that I use. This is, I think, like more helpful when you have your equation in standard form, but this is all right. We can just turn this into standard form. So the equation goes that when, or like the formula goes that when you have your equation in standard form, so when it's like ax plus by plus equals c, like this, then the distance from a point to that line, like that closest approach, let me get a new piece of paper. That distance is going to be, so I'll write closest distance right here. It's going to be equal to the absolute value of ax plus by minus c over the square root of a squared plus b squared, like that. And a is your a coefficient in your equation, b is your b coefficient, c is your c coefficient, and x and y are the coordinates, the x and y coordinates of your point that you're looking at, like in this case the origin, which is just 0, 0. So let's turn this equation into standard form. So we have y equals 2x plus 7. So I'll move the x to the other side. I get negative 2x plus y equals 7. But remember, in standard form, we never want our x or a coefficients to be negative. So let's just inverse everything. And we get our equation in standard form is 2x minus y equals negative 7. So my a coefficient is 2. My b coefficient is negative 1. And my c coefficient is negative 7. And so I'll plug this into the equation. So remember, x and y are my coordinates of that point. I want to see the distance from the line. So in this case, origin, which is 0, 0. So I'm going to do the absolute value of 2 times 0 plus negative 1 times 0 minus negative 7 over the square root of a squared, which is 2 squared, plus b squared, which is negative 1 squared. And so I type this on my calculator, And this is just going to be 7 on the top. The bottom is going to be square root of 5. Divide, and I get 3.13, which is my answer. All right, number 62 evaluates 14,782 raised to the negative 14,782 power. So 62 is always what we call an overflow question. So what I mean by that is, let's say for a typical overflow, like 5,000 raised to like the 98,000 power. When I type on my calculator, I get this overflow error. The calculator just doesn't have enough bits to calculate that number, and so it's like the calculator can't calculate that number. But we can pretty much estimate that number using this trick. So what I can do, and this is how you do any overflow, we're going to do the log. Okay, our first step is do the log of your base. So log of 14,782 is our base. And we're going to multiply it by our exponent, which is negative 14,782. So I'll write that on the calculator. 14,782 log 14,782 negative multiply. And I get this number, and you want to do yellow show. And you want to write this integer part, like after the decimal, like before the decimal here. So that'd be negative 61,636. Like you want to physically write this on your test when you're doing it. Because you want to keep this number in mind for later. And so what we're going to do with this number is we're going to type it on here. So negative 61,636. We're going to subtract it from the value we got from this expression. So that should only leave us with the decimal part of our answer. Okay, now what we do is we're going to do yellow 10x. So, like right here, yellow 10x. And I get 1.01 times 10 to the negative first. So you're going to write these first 3 digits, so 1.01. These are going to be the first parts of your answer. And now what the exponent's going to be, so you're going to write times 10. And the power here is going to be this number you wrote from earlier. And you add on whatever exponent you have here. So we're going to add on a negative 1. So it's going to be raised to the negative 61,637 power. And that's our answer. This is also like one of those questions where if you finish your number crunchers, like I would recommend this being the first question that you do. Because it's an easy one, you can get it right out of the way. Okay, 63. A projectile is fired from Aberdeen to American Falls, 16 miles away, at a release angle of 42 degrees. What is the minimum elevation of the projectile? Or maximum elevation, my bad. What is the maximum elevation of the projectile during this flight? Okay, so this really helps if you've taken a physics class. This is like the first unit of AP Physics, kinematics. Like knowing your 3 kinematics is very, very useful for this type of question. 63 is always something to do with trajectory and kinematics. And so I won't write all of the equations here. There's like an AP sheet out there somewhere that has them. But the equation I'm actually going to use is not any of those kinematics. It's like a shortcut to find the range and the maximum elevation of your projectile. Given that, there's no change in height. Like, say like you're passing like football on a field. Like this equation will work for this case, but it won't work like if you're throwing a football from like a 5-story building, because there is a change in height in that scenario. And so the two equations that you want to know here are that our range is equal to v squared times the sine of 2 theta, theta being the release angle, and v being the velocity, over g. Now what's g? G is your gravitational constant. There's 2 to memorize. Well, like, it's the same value, but just different units. G is either 9.81 meters per second squared, or 32.174 feet per second squared. So 9.81 meters per second squared, 32.174 feet per second squared. Those are the 2 constants you want to have memorized. In this case, because we're dealing with miles, we're going to convert miles to feet, and we're going to use the 32.174 as our G. But we're not looking for range. We want to look for the maximum elevation. And that brings us to our second equation. So our, say, max height, h, is equal. These equations are very similar. You want to make sure you don't have these confused. So our max height is v squared times sine squared theta over 2g. So we're going to use this equation. So we're just going to substitute the values that we know. Well, actually, we're going to use both. Actually, now that I'm rereading this. So we're given our range, and we're given our release angle. We want to know what the max elevation is. So actually, we have our range, we have our angle, we have our constant. We're going to solve for our velocity. And we're going to take this velocity, plug it back into this equation for our same release angle, and our same gravitational constant to solve for our max height. So my range is 16 miles. I'm going to convert that to feet. Remember the conversion from earlier? There are 5280 feet in a square mile. I mean, in a mile. So we multiply. Then we multiply by our constant, 32.174, and divide by sine of 2 theta. So if theta was 42, 2 theta is 84. Sine, divide. And that leaves us with our v squared, so we got a square root. That's our velocity. We're going to square it again, because we got to plug it back to this equation now. So v squared times sine squared theta. That just means you do sine of theta, so sine of 42, squared, multiply, and divide by 2g. And that gets us our range of about 19,000. Our height, our maximum elevation of 19,000 feet is our answer. Okay, last 2 questions. Last 2 geos. 64, we have this circle and this segment here. A segment of a circle is like this part right here. And so all the shaded area is like the area of the circle, which is not in the segment. We're given the radius and the shaded area. We want to know what this height is. So this is a nice question. There's a formula to memorize for the area of any segment of a circle. That formula is the area of a segment. So let me just write segment is equal, and you have to make sure you're in radians for this to work. It's r squared over 2 times theta minus sine theta. r squared over 2 times theta minus sine theta in parentheses. And so what I can do is I can use the area of a circle, like that formula, in this formula, subtract the two, set it equal to my shaded area. And then I can solve for my theta. Theta being, and what angle is that? It's this angle right here. Let me just draw the circle again. Here, theta would be this big angle right here between these two radii. And what I can do after I get my theta, let me just draw again right here, zooming in. I can half theta, so this would be theta over 2, this angle right here. And this little piece that I want to solve for would just be this whole radius, because this is a radius, minus this part right here. And remember, this is also a radius. So this part right here would just be this radius times cosine of theta over 2. So our r minus r times theta over 2, so this part, would just leave me with this part. So let's solve for theta. So I'm going to write an solve equation, so many 3, 1. So the shaded area, which is 11,600, is equal to pi r squared. Our radius was 21.1 minus r squared over 2. Again, let's just change this to radians right now. So r squared over 2 times theta, so x, minus sine of x, comma x, and I get my value of x in radians. So I take this value, I half it, so now I got this angle right here. I'm going to multiply my radius by the cosine of that angle. And I get that this piece right here is 11.5. I'm going to subtract that from my 21.1, which is just this full length, which is my radius. And I get my answer, this leftover piece, being 9.58. That's my answer. And our last question, 65. This one's an easy one. We have AB, which is 190, and BC, which is 113, and C is the center of the circle, and I want to know what this height is. So there's two triangles here. So there's this first triangle of hypotenuse AB, and there's a second triangle of hypotenuse CB. And an important thing to know about these triangles is that one has double the base of the other, right? Because this base right here is just one radius, and this diameter here is, well, this base is a diameter, right? So it's two radiuses. And also they share the same height. So we can write an equation that relates these two. So I can write the equation that height equals height. And I can express the big triangle's height as square root of 190 squared minus 2x, which x is just going to be my radius. So minus 2x squared. Remember, this is in parentheses. This equals, well, height equals height. In this case, I'm going to represent it as 113 squared minus x squared. Again, these are both equal to this height. And so I can use n solve. I get 190 squared minus 2x squared. The square root of that is equal to the square root of 113 squared minus x squared, comma x. And I get my radius as, so my x as 88.187. And now I can plug this back into either one of these equations to get my height, because that's what these represent. And so I'll just pick this one. So 113 squared, and then 88.187 squared, subtract square root. I get my height as 70.7, which is my answer. And that's the whole test. That took a long time. Alright, maybe I'll do more of these in the future. Yeah, you guys let me know. But yeah, that's the VCM3 from this year. Got a 336. And yeah, hopefully you guys kind of learn some stuff here, learn some equations to keep in mind for later. And yeah, alright, later.